Like Julia said, my name's Luke Banke. Out of Missoula, Montana. If any of you know where that is, I'm surprised. But today I'm looking forward to sharing with you an overview of a complex project that we worked on over the past few years. The University of Minnesota's Bell Museum of Natural History has recently relocated to their new facility. And one of the most significant aspects of the museum's relocation was the move of their world-renowned dioramas. This was an incredibly complicated process with many players involved, but today I'd like to show you the process of moving the large-scale painted diorama walls. Little background here. Established by the Minnesota State Legislature in 1872, the Bell Museum's history is one of preservation, research, and display of diverse plants and wildlife of Minnesota. In the late 30s, then president of General Mills and conservationist James Bell Ford helped provide funds to construct a dedicated museum building on the Minneapolis campus, which opened in 1940. The driving force behind the Bell's contribution was his desire to educate the public about Minnesota's diverse wildlife and habitats and encourage public support for their protection. It's kind of timely now, especially in his case, he was worried about declining species such as the gray wolf. The Bell Museum was designed specifically to showcase 16 large-scale dioramas, as well as many small and medium-sized dioramas. The diorama backgrounds were constructed of metal lath and plaster walls. Canvas was then adhered to the front of the wall and primed before the artist painted murals in situ. The foregrounds were then created in front of the painted murals and the dioramas completely encased. The first diorama constructed in the new space was the gray wolf diorama depicting the shores of Lake Superior. The background was painted by the well-known American wildlife artist and Minnesota native Francis Lee Jaques. Over the next 2 decades, Jaques painted a total of 9 large-scale and many small diorama backgrounds for the Bell Museum, creating an internationally recognized collection with a focus on Minnesota's wildlife and diverse ecosystems. So this is a picture of the old Bell Museum. Over time, the dioramas began to change, and the building around them posed serious challenges and limitations. Relates perfectly to the sustainability talk given earlier. This building was in terrible shape. It had poor climate control, recurring water infiltration, lack of handicap accessibility, and poor public access that created a need to discuss options. I mean, really, it was a situation where it was either let them languish or take risks. Relocation of the museum would include the move of Jaques' 9 large-scale dioramas and a 10th painted by Charles Abel Corwin in 1919. The planning phase also led to the creation of a diverse project team, including Bell Museum staff, university health and safety, construction crews, conservators, riggers, and museum specialists. At first, it was thought that the best method of moving the murals would be to physically remove the painted canvas from the walls. Examination of the painted murals by Midwest Art Conservation Center conservators, known as MAC, indicated that removing the canvas from the wall was not viable, as the majority of them were secured with lead-based paste. Removal of the canvas would severely damage the painted image and create a health hazard. And here you can see this image on the left, the back side of some of these walls. So you can see their construction. The steel studs, metal lath, and lime-based mortar were typical substrate for these kinds of paintings in the era. After the wall was constructed, the front surface of the wall would have been skimmed with plaster, and then the lead paste would have been applied, and the canvas finally. Because the canvas could not be removed from the walls without risking the integrity of the images, discussions began about removing the walls as a whole. However, several constraints of the building came to light. For instance, Concrete headers. You can kind of see it in this image. The wall was built up above the header, and you'll see it more in the other images. Concrete headers and close proximity of the walls to each other. They locked the murals into place. They were very difficult to get out. And there was also a lack of a large opening to move the murals out of the building. Therefore, the best option was to move the mural walls in 3 parts. A plan was developed in which the murals would be stabilized, cut, secured with an armature, and rigged out of the building. To work out the logistics of how each team would be involved, a test move on an unwanted diorama was carried out in January of 2016. After the test was completed successfully, the project was fully approved, and in January 2017, the diorama move began. The first phase was carried out by McGough Construction, who was the main contractor for the project. The glass windows in the front, wall paneling, and all non-structural building materials were removed from the front of the dioramas for access. All of the foreground material needed to be removed next. Each plant, leaf, and animal was meticulously moved and prepared for cleaning and transport. This work was carried out by Terry Chase, Terry Brown, and Split Rock Studios, and I mean, this was monumental. They photographed everything very carefully. They collected every twig, every sample, every flower, every bit of moss. They recreated every wax leaf that was damaged or melted. They recolored every single animal and reconditioned every single specimen. It's thousands of hours of work. Once all the loose material was safely removed and cataloged, the platforms were carefully deconstructed for removal. It's kind of interesting to note, these platforms, their construction was incredibly cheap. And it's because it was war era. The materials were very expensive at the time, so it was like pallet pieces and things that made up the structure of all these bases, so they were kind of funky to get out. This is the moose diorama after all the building material and foreground had been removed. This was the first time that the mural crew had full access to each wall. While the test move allowed for a general understanding of how teams would proceed, details such as pigment solubility and type of adhesive used to adhere the canvas to the wall, in each mural was unknown. So they didn't know what made up the pigments. They didn't know what the glue was. So MAC carried out solvent testing with all the pigments to ensure that their facing plan would be acceptable and not do damage to the paintings. As it turned out, the planned method of facing would only work for 8 of the 10 murals, the large murals, and a second facing option had to be developed in addition. So they also identified all the adhesive for each individual murals of the murals. 9 of them had the lead-based paste that we discussed earlier, and 1 of them had a protein glue. Murals were dry cleaned with vulcanized rubber soot sponges. Many people were surprised at how nasty they were. You can see the line where she's cleaning. They weren't encased very well. They weren't sealed very well. It's important to keep in mind conservators had to deal with this active construction site. Foregrounds were still being removed from adjacent dioramas. Walls and ceilings were being torn out nearby, and there was a constant generation of dust and debris. Despite the added chaos, the next step was to apply all this facing to the front of the murals to protect the painted surface from dirt, abrasion, and general construction hazards. 8 murals that tested stable were faced with 30-inch by 40-inch sheets of lens tissue. sprayed with 3M's classic Super 77 adhesive. This material was chosen because it had been used by MAC conservators successfully on past off-site mural projects and was considered to be fast, effective, and easily removable with naphtha. It was also used during the test move to confirm that it would work prior to testing it out on the real deal. For the two murals that were sensitive to solvent, a totally different approach was taken. MAC conservators created pressure-sensitive adhesive-backed paper sheets, which were then used like tape to secure large runs of Dartec across the surface. Because the walls were removed in 3 parts, the canvas would need to be cut. In order to create the least amount of damage, MAC removed a 2-inch strip horizontally across the entire mural. A second vertical 2-inch strip was also removed to create a T-shape on the wall. The first step in this process was to determine where the cut line would fall. It was made in collaboration. I worked with MAC based on all of our needs while keeping in mind consideration for details. For example, in this painting, we didn't want to run through the head of the pileated woodpecker. Cuts were made with the aid of the laser line and the old-fashioned way with the confiscatable utility knife at the airport. After the cuts were complete, the strips were slowly chiseled off. Now, we couldn't take the whole canvas off, but we found that little localized bits, the conservators figured out that they could risk that because it wasn't creating immense amounts of damage. They felt like it was a manageable size task to repair any of that. They're chiseled off the wall and rolled onto the sonotube, and you'll notice the protective gear, HEPA vacuum because of all the lead. So there's that T shape. Strips were taken back to MAC's studio, and all the lead paste and any plaster was cleaned off. And then they attached Viva to the back of the strips for reattachment later. Wrapped everything up back on their sonotubes. So did I mention earlier that the walls of the murals were built in place and never intended to move? When we started looking at them to cut them, we had like 2 major concerns. First, we needed to make every effort to keep the main portion of the image as large as possible and still able to move through the space. Our second consideration had to do with the image itself. Most of the images had extremely well painted skies, very subtle transitions, and coloration was really exquisite. So if we were to cut it in the sky, it would have been nearly impossible to adequately repair the image without leaving visual evidence of the cut. I figure we would have had to send an envoy to the Netherlands to try and conjure up Vermeer from the dead or something to fix it. Therefore, we kept the cuts lower in the image, and were able to use the complexity of the scenes. Often there was a lot more visual density going on down lower. And then foregrounds tended to obscure things. So if there were issues with the cut or the repair of the cut, it wouldn't be that noticeable, was the thought. Our structural cuts were made in the center of the 2-inch strip where the canvas was removed. This 2-inch zone provided adequate space for us to make a 1/4-inch wide cut, like about a 4 mil cut, with plenty of buffer on either side to protect the painted surfaces. During all of this cutting, there was tons and tons of cutting. We had to use active and passive controls, environmental controls to prevent our exposure to silica and silicon carbide, to lead. There was also arsenic. These things were loaded with arsenic to preserve all the specimens. Here we're starting to build the armature out. When we began this cutting process, we would only make strategic cuts on the wall. We obviously couldn't just go through and cut the whole thing. It would just fall down. So we made cuts that enabled us to attach our armature first. Diorama walls varied in thickness and size, so it was necessary to assemble the armatures in place. Here you can see this main truss span that we're building. All the armatures had this main truss span, which helped to prevent those side walls and that shape from moving around too much. Also note here that here's like a couple of those cuts I was talking about. See how it's solid here? There's a cut here, it's solid here. That enables us to build this armature and sort of engage the wall. So you've got the main truss frame here. Then we're building back these perpendicular trusses that engage this piece, which ultimately carries the whole load of that top section. Continue building this out. And you can kind of see progression of the dioramas in the space. There's welded and bolted connections in the armature. So what we did was we made it all in these different parts, and we wanted to be able to, when we had to reassemble them and get the steel out of there, we didn't want to have a bunch of grinders in there cutting all the steel apart. So we had bolted connections and then several main parts. This portion of the project was an arduous 16 weeks. 6 fabricators, part of us from Wolf McGreed, part from Methods and Materials. We all worked together on this. It was insane. I mean, arduous, dirty, tons and tons of steel. So then you see rows of these things kitted out, ready for removal. You can see the top sections we did in the steel. We built wooden armatures that followed the curvature of the wall, so that when we'd eventually extract them, we'd be able to attach them to the wood armatures. The bottom sections of the walls ended up being about 500 pounds, 250, 220 kilos. And the top sections would range anywhere from 3 to 4 tons with all the steel. Once the armature was complete, crib towers were assembled and jacks put into place to take the load of the upper sections of the wall. So we put some pressure underneath this big armature that we made, and then we could finish our cuts. At this point, the upper wall section is just sitting on the towers and separate from the lower parts of the wall. This enabled our crews to extract the bottom portions, which we affectionately labeled noodles. Pulling these noodles out. And after we extracted each noodle, we just put it onto its wooden armature. It seems like you're zoomed out a little bit, or zoomed in a little too much. Is there any way to zoom out a little? No? Okay. Can you hit play on this? So here you're seeing us lifting up the top section just enough. We had an inch worth of clearance on the top. So we had to lift it up just enough to be able to start to extract the bottom sections of the wall. And a few poor members of the crew spent hours and hours and hours cutting underneath the walls with a reciprocating saw. And they had these nails that they must have forged out of, I don't know, adamantium or something. They were so hard. You hit play on this one. So after we have those sections out, we could lower the top. You see it kind of moving around. It's because it's on a 3-point jacking system, but you also notice that it's staying very stiff, very rigid. Components were then boat wrapped. Nod to the boat wrap. Prior to their journey from a large hole that was made in the side of this historically protected building. Just let's cut it open. They saved every single piece and put it all back together when it was finished. But we rolled out all the parts, the boat wrap pieces, onto this platform so they could be craned. 2 trucks. I thought that was a nice sky. I don't know if it's as good as the murals, but traveled to the new museum, reversed the process. Pieces lifted off of the trucks, up onto a platform, and thankfully McGough was considerate enough to leave us a big hole in the side of their building. That we got all the components into the building, rolled them in, after which they promptly sealed it back up. The next step was to reverse the process. Each diorama had a custom niche with about 6 inches average clearance around. Therefore, the walls had to be reassembled in front of their niche due to the structural repairs we had to make. So every single stud had to be tied back together, and we had to do some plaster repair on the backs. The 2-inch strips of canvas that had been removed provided the perfect registers. So we just lined up the image to make the walls match. But this process was pretty arduous. It took a long time to get the exact cant of the wall to line up properly. But once it was, the seam on the front, we faced it with the blue masking tape and vinyl tape. And then the joint was filled from the backside with a 2-part epoxy. And then once the gluing's complete, we utilized steel from our armatures that were coming apart and welded it all back together on the backside. When we assembled the walls, we put them on top of these plates that we had where we left little voids. The plates were made out of plywood and they had steel screwed to the top, and we welded them to the whole assembly. But we left those little voids so we could get the machine skates inside. And we left the front portion of the truss on there until we had them rolled into place and set down on the ground. Ironically, this move would have been feasible without the lead glue that prohibited the peeling of this canvas, in my opinion. The canvas glued to the lime mortar and steel wall structure provided the necessary local tensile strength across that surface for the compound actions that this undertook. One of the murals that we did move that didn't have the lead glue, it was very fragile and prone to breaking all over. So that fabric glued to the surface provided that awesome tensile strength. And the lead glue was almost impossible to get off, so. As soon as the wall was in its final placement, conservators got back to work. They started cleaning up all the edges, filling, knocking down anything that was proud. They had to make that perfectly level, and they kept testing their pieces as they went along. You see them, conservators testing these strips one final time. It's ready to be for the strips to be reapplied. And there they're using the heat set Viva, glue them in. After they did that, they filled the seams top and bottom and removed facing. Used, like I said earlier, used naphtha to remove all the facing and the glue. And then practice being Vermeer. Hours and hours of in-painting. But they did a pretty outstanding job. So I just run through these. I think they're actually pretty amazing things after they're reassembled. This is the elk diorama. The moose. Big dumb birds. I mean, sandhill cranes. This one's titled Lake Pepin. Cascade Falls. There's all kinds of cool stuff hidden in them. Snow geese. The gray wolves. It's called the Big Woods, and our friend, the pileated woodpecker. Beavers. The image isn't so great on this one, but it's my personal favorite. It's the swans. You know, and since there was so much was talked about collaboration, I mean, this was a monumental effort. Everyone worked very hard on it. Everyone listed here was actively involved. It was truly a once in a lifetime event for this kind of thing. I mean, a lot of people said it couldn't be done, and we worked it out. It's a fun time. Good team. Thanks.